Educating Matt Powell, Part 3. Now, some of you may be thinking by now, looking at some of the things Matt said, that I'm really dealing with low-hanging fruit here. But low-hanging fruit still needs to be addressed because there are still people that listen to people like Matt Powell. Looking at his YouTube channel, that's not a whole lot of people. He's only got 2,069 subscribers. But there are a lot of people like him out there right now. And cumulatively, that message is getting out. And it may only be foolish or deluded people that listen to people like this, but nevertheless, there are still people that listen to people like this. Look at what he's promoting just here on his cover page. Science Falsely So Called, the film that debunks the theory of evolution with science. Just looking at the little clip that came up when I looked at his site, it starts blaming teaching the theory of evolution for things like high school shootings. Well, even if it were true that high school shootings were caused by people believing in the theory of evolution, that wouldn't make evolution any less true unless you're using some sort of weird Jordan Peterson type definition of truth. Now, without wanting to wander too far off track during this intro, let's just look a little bit further at this that he's promoting. We're going to take a deep look at the fossil evidence for the flood. There was no flood. I'll probably do a series of videos on this at some stage, but Noah's flood is one of the most ridiculous stories amongst many ridiculous stories in the Bible. And look at this. They're going to take this journey with a very well-known scientist, Dr. Kent Hovind. If you're not aware of who Dr. Kent Hovind is, then perhaps you should look that up. And while you're doing that, have a look at his doctoral thesis. It's available online. This is not a doctoral thesis. Go to a university and look at some doctoral theses. You will find that his bears no resemblance to them. Why? Because he got his PhD from a Christian diploma mill. Basically, he got it from a porter cabin. Okay, rant over for now. Let's get back to the conversation.
I've never heard... Here's the thing though, man. Like, okay, sorry, I didn't mean to cut you off. Did you want to finish? I was just going to say, I look at these arguments that they're making, and they're saying, well, we can measure the rate of burn in the sun, based off telescopes. I don't think that's possible.
So why?
Within just a huge... It's definitely not possible, because if the sun is burning up, you have to look at the mass of the sun, how big it is. The eye of the you have to take so many things into consideration. And even then, there's no way we could zoom in close enough, even with all the technology that we have, to look at the radius, of the sun. There's no way. And so, I really think the argument falls apart. I don't think it's a valid argument. I think it's crazy.
Okay, I know what you're going to say. We've covered this. Matt says that he can't see how we could possibly measure the burn rate of the sun. We know from earlier in the episodes that we could do it with a bucket of water and a thermometer. Now I want you to watch this next clip carefully, because I promised all along that Matt actually thinks that the sun is burning. And this is where that comes out. And what I want you to pay special attention to is Jackson's face after he says it. It's priceless. He looks like he's been hit with a baseball bat.
It's more about we can infer this is happening based on how we understand a hydrogen fusion. We understand how they can form to make helium, and we understand, like I said, Einstein's equation equals...
I see what you're saying. Yeah,
and so we can make this inference based on what we do know without having to directly see it. Like, for example, we can't directly see electrons, right?
Mm-hmm. Yeah.
But we know electrons exist because we can utilize them all the time, like we're doing right now.
Sure. But in space, wouldn't it be a different scenario based on the fact that, the the space and the air in the space is much different than the air we have here in our area. So I mean, it's just, we have to take that into consideration. There's so many things you'd have to take into consideration, because we are not, I mean, if we went into space, we'd suffocate, you know.
Are you
And
suggesting that because things need oxygen to burn, and there's no air in space, obviously that's not occurring? Because I think what Jackson was trying to say, I am by no means somebody to explain this to anyone.
I'm not either.
So we'll get back on paleontology shortly, but I think that because it's a fusion, the oxygen that you're referencing isn't required for that activity to take place.
Right. There is no oxygen required. This is about the mass of the sun pulling these atoms together, which is causing them to fuse.
I can definitely see where you're coming from, but you know, again, I think it comes.
The air in space is different. No shit, Sherlock. We would suffocate if we were there. Again, no shit, Sherlock. I can see where you're coming from. So, Matt, you say that you know where we're coming from, but I think it's pretty clear from everything you've said so far that you've no idea where we're coming from. So it's clear that Matt actually thinks the sun is burning, like it's burning a fossil fuel. So we're going to run with that model and see where it takes us. So the diameter of the sun is about 1.391 million kilometers, and that means the radius is half of that. And it's approximately a sphere, so we'll say 4/3 pi r cubed. Substitute in the radius and calculate. And we get that the volume of the sun is 1.409 times 10 to the power 27 cubic meters. This is absolutely enormous. If the sun were literally burning a fossil fuel, coal or natural gas for example, we've got to ask ourselves some questions. Where did it come from? Where were the gigantic carboniferous rainforests that produced the fossil fuels for the sun? Never mind all of the other stars in the universe. Did God just create this stuff? And secondly, where does all the oxygen come from that would be needed for the combustion of all of that fossil fuel? So Matt, what do you think the sun is actually made of? What do you think it's burning? If it's made of something like coal, where did all the coal come from? Did God create all the coal for all of the stars in the universe when he created the universe? What about all the oxygen to burn that coal in? What did he do with that? I'd love to ask you these questions. I really would. So we've looked at this before. The sun is losing about 6 times 10 to the 12 grams per second. Well, hold on a second. That's with fusion. That's not what's happening if it's burning like a fossil fuel. At any moment, the sun emits about 3.86 times 10 to the 26 watts of energy. Remember, that means joules per second. So if all of this energy were being produced by burning of coal, for example, how long would the sun have left? Well, I managed to find this. A pound of coal produces 1.6 times 10 to the 7 joules. So we want that in kilograms. So all we need to do is multiply by 2.20462. And we get 3.527 times 10 to the 7 joules. So the mass used in 1 second would be 3.86 times 10 to the 26, that's how many joules the sun produces in a second, divided by the energy produced, the number of joules produced, by 1 kilogram of coal. So therefore, it would need to be burning 1.094 times 10 to the 19 kilograms of coal every second. So how long will the sun last at this rate? So we have 2 times 10 to the 30. So that's the 2 times 10 to the 33 grams converted into kilograms, divided by the number of kilograms of coal that we would need to burn in a second. And that gives me 1.828 times 10 to the 11 seconds. So we'd like that in more realistic units. So if we take our 1.828 times 10 to the 11, divide by 60 to get it into minutes, divide by 60 for hours, divide by 24 for days, and divide by 365 for years, and we find that's about 5,797 years. The sun, under Matt's model, would have another 5,797 years left to burn. So, at risk of repeating myself, if the sun were burning in the way Matt thinks, it would only have 5,800 years left. Does he really think that we couldn't detect that? I remember him saying that we've only had telescopes for a couple of hundred years or something. Consider that under Matt's model, the volume will just reduce as the sun burns, and we know, because we've discussed this, that that's not actually what's happening or what's observed at all. So, the first solar radius measurements, let's take this as a worst case scenario, were in 1682. That's 337 years ago, and they say that the accuracy is about 0.8%. At this time, let's project backwards, the sun would have had 6,134 years left. Remember, that's under Matt's model, so I've just added the time for the measurement onto how long it's got left from our current measurements. Okay, so the percentage of its mass and hence volume, according to Matt, lost since then would be as follows. 337, that's the years, out of the 6,134 it had left at that point times 100 is 5.494%. Now we can calculate the approximate change in radius using a little bit of calculus. So, volume is 4/3 pi r cubed, which means dV/dr is 4 pi r squared. That means that the change in volume over the change in radius is approximately 4 pi r squared, and therefore the change in volume is approximately 4 pi r squared times the change in radius. Now let's do this as a percentage. So we divide both sides by the volume, so we get delta V over V. On this side, I divide by the volume written as 4/3 pi r cubed, so that we can do some algebra with the 4 pi r squared here. And if we do that, then what we find is that the change in the volume is about 3 times the change in the radius. Or, if you like, the change in the radius is about 1/3 of the change in the volume. So the change in the radius will be about 1/3 of that 5.494%, which is about 1.83%. Now you should notice that this 1.83% is an awful lot bigger than the 0.8% error in measurement back in the 17th century. That's the accuracy we would have had in the 17th century. And still, between then and now, we would definitely have detected that change in the radius. What about if we use current measurements? Well, in an earlier section of this, I told you that the modern measurements are thought to be within about 65 kilometers. So 65 kilometers as a percentage of the sun's diameter, That's about 0.0046%. So there's absolutely no chance that we wouldn't detect this sort of difference. We would detect this sort of difference in a very short span of time. So Matt, you've said a few different things, and every single one of them's been an epic fail. I wonder if you can keep that record going.